Hello, tonight our video is on rate of change again. This is part 2. So consider the graph in front of you. Here we have a graph of where the y-axis represents distance in miles and the x-axis represents time in hours. Let me go ahead and label those. Here's your x-axis, here's the y-axis. Alright, so looking at this graph, we could write a rule based on these points that are given. All right, so our rule is going to be the dependent variable y is equal to something x and then plus something. All right, so let's look at the value of y when x is 0. Just like in a tile pattern, we would look at the number of tiles in figure 0. Well, looking at our graph, when x is 0, the value of y is also 0. The distance traveled is at 0. So we would put a plus 0 there, or we could just leave it off, but that's what would go on this part of our rule, right? The initial figure, if this was a tile pattern, would have 0 tiles. But this is not a tile pattern. This is just a graph of something traveling over time. So the initial value would be 0. Now, that's not really necessary to leave it in our equation, so I'm going to go ahead and erase it because any number plus 0 is not going to change. Now let's look at the rate of change, the amount that the distance goes up by for every one value of x.
Mrs. Schmitz, please call extension 2002.
Okay, so looking at the amount of change, when x changes from 0 to 1, right here, the value of y goes up from 0 to 5. And then as x changes from 1 to 2, the value of y goes from up 5 from 5 to 10. So it looks like every time x increases by 1, the value of y increases by 5. So if this was a tile pattern, it's increasing by 5, plus 5 in the y direction. And it's not a tile pattern, it's a graph of something traveling, but it's still the same idea. The increase is 5 for every 1 hour. So the growth factor is going to equal 5. The number 5 would go right here in front of the x. So this is the graph of the equation y equals 5x. So therefore, if x equaled 4, y would equal 20, right? And it would be right here on our graph. All right, now consider this graph. Here we have two line graphs representing distance traveled again in hours, and they're two different bikes, so two different bicyclists, bike A and bike B. Notice that they both have the same initial distance traveled. Before time starts to go by, they're both at 0. All right? So let's look at the two graphs and let's find the rate of change for each graph. Let's start with the red one. All right? So I can see here that when 5 hours passes, right here, so after 5 hours, the bike A would travel 1 mark above 50. So that's going to equal 60 miles. All right? So let me write that down. Bike A traveled 60 miles in 5 hours. Now this is a straight line. So the rate of change is going to be the same everywhere. All right? And let me double check that. Let's say that bike A traveled for 10 hours. Then the distance it covered would be up here. That is 2 marks past 100. That's 120. All right, those two ratios should be the same, and they are. They both reduce, if we're going to put this as a rate, they both will reduce to the same number. They both reduce to 12 over 1, or just 12. So the rate of change for the bike A is going to equal 12. So that means that bike A was traveling at a rate of 12 miles per hour. 12 miles every 1 hour. Now let's look at bike B. Bike B, after 5 hours, travels a distance of 40 miles. And again, it's a straight line, so after 10 hours, it travels 80 miles. So what would be the unit rate or the rate of change for bike B? Well, if you said 8 miles per hour, you would be correct. All right, so let me write that. All right, so notice that bike B is traveling at a rate that's lower than that of bike A, and therefore the line is less steep. It's a little bit flatter. And that bike A is traveling at a higher rate of speed, so that line is a little bit steeper. All right, let's go to this graph. Here we have 2 plants that the growth of the plants have been charted on a coordinate plane. And you can see that this time the initial heights of the plants are not 0. Okay, so these were plants that were really small little plants that were like maybe transported or transplanted to a different pot, and they had different heights. Okay, so plant A had an initial height of 4 centimeters. Okay, so if I was going to write the equation for the growth of plant A, okay, it would be, oops, let me get the right color here. All right, so if I'm writing an equation for plant A, I would put a +4 to show that after 0 weeks of being planted, it had an initial height of 4 centimeters. Now, as I look here, it looks like for every week that goes by, the plant increases its height by 1 centimeter. You see that? So after 1 week, it's now 5 centimeters. After 2 weeks, it's at 6 and 7, and it's consistent. So the equation is going to be 1x because the rate of change is 1. All right, so y equals 1x plus 4, or you can just say y equals x plus 4, same thing. All right, so there's the rule for plant A. And then plant B, let's get a different color. Let's get blue. All right, so the initial height for plant B is 8 centimeters. So this is going to be a +8. And now let's look at its growth. It looks like it takes 2 weeks to grow 1 centimeter. See that? After 2 weeks, the plant goes from 8 to 9 centimeters. And then after 4 weeks, it's up to 10. All right, so that means it's changing at a rate of, what do you think the rate would be? How many centimeters is it growing per week? Well, if you said 1/2, you're correct. It's growing at the rate of 1/2 of a centimeter every week. Okay, because it takes 2 weeks for it to grow 1 centimeter. See that? So 2 weeks to grow 1 centimeter. So it's a rate of 1/2. Notice that since its rate is less than 1, it's flatter. And eventually plant A will pass plant B in height. But after how many weeks, look at the graph carefully, after how many weeks will both the plants be the same height? Pause your video if you need to. All right, welcome back from pausing the video. So I'm looking for the point where they're both the same height. And it looks like it's going to be this point right there. So that would be after 8 weeks. So after 8 weeks, both plants are the same height. See that? And then plant A will surpass plant B. All right, let's go to our last graph. here we have two cell phone carriers. And so this graph shows the cost in dollars per month for cell service. And it looks like our x-axis is going to be the data in megabytes. Okay, and the y-axis is the cost. Okay, so let's go ahead and let's write the rule for carrier A. All right, so the initial cost before any data is used up for carrier A is right here. It's $10, so that's a plus 10. All right, and then the rate of change is going to be based on the data usage. Okay, and that number is going to go in front of the x. All right, so let's look at the graph. What is the rate for the data? Pause your video and then restart to see if you got it right. Welcome back from pausing the video. If I'm looking at the red graph, here, 0 data is used up. The initial cost is $10. Okay, after 10 megabytes of data is used, the cost goes up to 20. So that means that the cost went up $10 for 10 megabytes of data. And then if I go from 10 to 20, the cost went up another $10. So it looks like the rate is going to be $1 for every megabyte. So 1 would go in front of x, so I can just leave this the way it is. So there's the graph, or the rule for the red graph, y equals x plus 10. Okay. Now let's look at carrier B. If I'm writing an equation for that, it's going to be y equals, okay, when x is 0, the initial cost is 20, so this is going to be plus 20. All right, and so now I need to figure out the rate of change, the cost in the data. So let's see, on the blue graph, after 10 megabytes is used, the cost goes up $5. Okay, then another 10 megabytes is used at the 20, the cost increases another $5 to 30. So it looks like the rate of change is going to be $5 for every 10 megabytes. So that would reduce to $1 for every 2 megabytes. So the rate of change is going to be 1/2 again, just like the previous example. All right, and then based on those two graphs, how many megabytes of data would be used where they both would cost the same amount? So at what point on the graph do they both cost the same? Yeah, if you said after 20 megabytes, you're right. So under both these cell plans, if the user used 20 megabytes of data, they would both pay $30. It would be the same cost. But once you get past 20 megabytes of data, carrier A is more expensive. So carrier B is actually a better deal if you use more than 20 megabytes. All right, that's all for tonight. Thank you for listening, and as always, read some books.